Today, I will talk about polynomial linear regression. Let's see a problem. In a company, we know some employee's label and salary. For a new hire, we know his label. Can we predict his salary? For such a problem, it has only one dependent variables. To understand how to solve such a problem, let's have some background knowledge. Today I will talk about equation. What the equation means? Equation means equality of two expressions. We can see some examples here. X equals 1. This is the equation. Y equals X. For example, if X equals 3, then for this equation, Y will equals 3. If I equals 5, then Y will equals 5. Another example is Y equals 2 times X. We can also see another complex equations like this: Y equals X times X. For such an equation, if X equals 3, then Y will be 3 times 3, then Y will equals 9. We want to draw those equations on the graph. Can you draw this graph for these equations? We have some equations: X equals 1, Y equals X, Y equals 2 times X, Y equals X times X, and sometimes we can use this written format that use 2 at the right corner. We call it square of X. The below equation is Y equals X times X times X. We can also express this. We call it cube of X. Can you stop the video and draw those graphs? Let's give some example. The first one is Y equals X. For this equation, when we draw it, we will see it's a straight line. We can also draw Y equals square of X. This will be a curve. For the cube of X, it also a curve. It seems for the second and third graph, they are all almost the same. But if you put them together as a below graph, you can see that the cube of X is much higher than the square of X. Now let's go back to our problem for the salary and also its level. We already have such red points on the graph. And for such a one dependent variables problem, we can use previously linear regression. But the linear regression can only draw a straight line, like the right corner, the picture. We can see most red points are not on the straight line. So this means it has much inaccuracy. If we use polynomial regression to predict, we can see that at the right down corner, we can see that the blue line will hit almost all the red dots. This means the polynomial regression has a much better fit for this data set. Why polynomial regression is better than the linear regression? It's only because the data distribution and the equation. For this linear regression, its equation is y equals b0 plus b1 times x. This will be a straight line. For the polynomial regression, the equation is y equals b0 plus b1 times x plus b2 times square of x plus blah blah blah. This will be a curve. So for such a data set, it's much better than the linear regression. In summary, polynomial linear regression can help us solve the problem that have one dependent variables, but the data set is not fit for the linear data sets. It uses the polynomial equations like this: y equals b0 plus b1 times x plus b2 times square of x. If we use Python to predict the data set, we can see it's already there, and it's much the same as the simple linear regression. Okay, that's all for today. Thank you.